Functions are denoted like this, typically with f of x is equal to some expression in x here. Here's a different function, g of x, again, is equal to a different expression. Now, one thing we can do with functions is we can think about inputs and outputs. Now, the input here is represented with the x. So the input will go here, and we would times 2 and add 7, which will result in a certain output. Here, the input again is represented with the x, so we can input something here, times by 3 and take away 2. Now let's have a look at how that's written. Suppose we were to find what f of 3 is. Now notice how the x has been replaced with a 3. Now for this part, we would also replace the x with a 3. So this would look like 2 times 3, add 7. I can now calculate this. This is going to be 6 add 7, which is 13. Suppose we wanted to find what the result of G5 is. So here I've replaced the x with a 5, therefore I replaced this x with a 5, so my input was 5, and let's see what output we get. So 3 times 5, take away 2, this gives us 15 take away 2, which is 13. Now it goes further. We can write, for example, f of 2x. Now think about what's happened here. Where we had x, we now have 2x. So we need to substitute 2x into this x. So that will look like we will have 2 times 2x this time plus 7. So notice how we still have 2 times something like we had here, 2 times the 3. Here we've got 2 times 2x plus 7. Now this doesn't give us any specific output yet. It gives us another expression, which is 4x plus 7. We could also do something similar on the other side. For example, we could have had g of x plus 2. So here what we've done is we've replaced the x with an x plus 2. So we're inputting x plus 2 into our function, 3x take away 2. So this is going to look like 3 times x plus 2 take away 2. Now again, this would result in the expression 3x plus 6 take away 2, and that simplified would be 3x plus 4. In these functions, we can say that the f of x here is a representation of the output. What I mean by that is if I was to use this expression with some input for x, the result that I get is f of x, because I worked that out, and that's going to be equal to f of x. So this here, we can say that this is another representation, or another way to say output, and here g of x is representing the output. So if I was to say f of x is equal to, let's have 13, and we're asked to solve f of x. So we're asked to solve f of x is equal to 13. What that means is I need to find the value of x when f of x is equal to 13. So I can substitute 13 here for f of x and then solve my equation for x. Now I'm going to write the 2x plus 7 first, just because it looks a little bit easier that way. 2x plus 7, and I'm going to say that's equal to 13. So notice what I've done. I've just put the 2x plus 7 here. Because f of x is 13, I've put f of x, which is 13, here. Now I can solve that by subtracting 7 from both sides, and that gives me 2x is equal to 6. And now divide both sides by 2, x is equal to 3. So what I've done is I've solved f of x is equal to 13 for this function here, which is defined. Let's try g of x. So let's try and solve g of x is equal to 0. So this time g of x is 0, so I'm going to substitute 0 into here, and I'm going to say 3x take away 2 is equal to 0. So 3x take away 2 is equal to 0, and I need to solve that for x. So I'm going to have 3x is equal to 2, and x is equal to 2/3. Sometimes we need to combine functions together and make composite functions. Now I'm going to show you how I'm going to have an input for g of x, and we're going to get some output, and then I'm going to use that output and input it into here, into f of x, and get an output. And then what I'm going to show you is how we could have just combined them in the first place and find a new function. So let's work out what g of 3 is. So g of 3 would be 3 times 3 take away 2. That would be 9 take away 2, which is 7. Now what I'm going to do is so this is my output for g of 3. Now I'm going to input that into my f of x and find something for that. So I'm going to say I'm going to find what f of 7 is, which is equal to 2 times 7 add 7, and that's 14 add 7, which is 21. So notice what I've done. What I've done is I've input something into g of x, and I got some output, and I used that output into f of x, and I got another output. So what I did was I used my function g of x, and then I put that into f of x. Now that can be denoted in this way. So we can say that was actually f of g of x. We can say it was that. So this is inputting g of x into f of x. This is also written as f g of x, like that. It is written in a few other ways, but we're going to stick with these ones for now. Now what I'm going to do is I'm going to find a function for f g of x. What that would mean is I input my g of x function into f of x. So that is inputting 3x take away 2 into the x here. So what that looks like is, well, I can say it looks like this as well, f and then 3x take away 2. Notice how g of x is equal to 3x take away 2. I have that here. And then this is replacing the x here, so I'm going to replace this x with this. So let's write 2 times 3x take away 2 add 7. Let's multiply out and simplify. This would be 6x take away 4 add 7, and then this is going to be 6x plus 3. So my function, when I use g of x into f of x, which is denoted like this, is 6x plus 3. So f of g of x is equal to 6x plus 3. Now a useful task would be to find what g of f of x is. So do that for homework. Up to now we've thought about inputs giving us outputs. Now how about if I was to take the output and get my input back? So let's think about inputting. So let's input 3 into f of x. Okay, 3 into f of x. So I could write it in a different way. So what I'm going to say is I'm going to take 3 and I need to times 2 first, and then I need to add 7. So I'm going to say I'm going to times 2, which gives me 6, and then I'm going to add 7, and that gives me 13. So when I input 3 into f of x, my answer that I have as an output is 13. Now what if I want to take 13 and go back to 3? Is there such a function? So let's see what that might look like. So if I was to take 13, if I take away 7, that gives me 6, and then if I divide by 2, that will give me 3. Okay, so there is a function that takes me from my output back to my input. Now that's the inverse function of f of x. So the way we come to that using algebraic method, instead of writing it like a function machine like this, is first we're going to say we're not going to use f of x because it can get a bit messy. Instead of f of x, I'm going to write y here. So I'm going to start by saying y equals 2x plus 7, and the y is going to represent the output. So we're going to say y equals 2x plus 7. So here, this is the same function as I have here. It's just that the f of x is represented by a y, or I can say that the output is represented by a y. Now, if I rearrange this and say, okay, I can have y take away 7 is equal to 2x, and then if I divide by 2 on both sides, I'm going to get y take away 7 over 2 is equal to x. I'm just going to rewrite that. I'm going to say x is equal to y take away 7 over 2. Now, we have to think about what the y and the x represents. Now, the y represented the output of my function when I input something into x. Now, the x represents the input. Now, this here is a function that when I take my output and do take away 7 and divide by 2, it gets me back my input. Now, to denote an inverse function for f of x, what we write is we write f minus 1 like this and x. Now, this minus 1 isn't a negative 1 power. This is just a notation for the inverse function of f of x. If I was to find the inverse function of g of x, I would denote it with g minus 1 and x. Now, the function that takes me from my output back to my input is take away 7, add 2. Now, remember, when we write functions, we write them in terms of x. So this function is in terms of x. This function is in terms of x. This function is in terms of x. Now, the function is take away 7 over 2. Now, I'm just going to write x take away 7 over 2. Now, this is now a new function, okay, and x is my input for this function, and the output that I get is f minus 1x, which is the inverse of that. So, to show how to get the inverse function of any function, replace the f of x or g of x or h of x with a y, rearrange it to make x the subject. Then we're going to replace the x with this new notation to denote the inverse function, and we're going to replace the y with an x because we write functions in terms of x. Now, I'd like you to show that the inverse function for g, so g minus 1x, is equal to h of x. So do that as part of the homework. Here are some questions that I'd like you to answer for the lesson.